In this video, we will be taking our cleaved fiber ends and we will be installing them into the West Penn Brilliance connectors. We'll be testing them with the Ideal Fiber Master optical loss test set, and I'm going to show you how to do it, and the connectors are going to work and they're going to be great. Now we're at the point where we're going to install our West Penn Wire Brilliance connectors, and here they are. Now this is the LC version of the connector. These are the single most popular connectors being used today in new installations. Now in installations in the past, connectors like the SC, this one, it's a square connector, and a round connector called the ST or Sam Tom were very commonly used, and they're still commonly used today. However, in newer installations, they're using these LC connectors, and there's a couple of reasons for that. One of them is they're smaller, and because they're smaller, we can put more of them into a piece of real estate on a patch panel. You can have more of them on that patch panel because they're smaller. And they work quite well, and they're also, because they are pushed, they're click in, click out, you don't have to put your fingers around them like you do with the round connectors to twist them so they come off. You just have to get top and bottom on them and squeeze them and they'll come out. So here are the two connectors that we'll be installing. Along with that, we have the connector jig. Now this appliance, whatever you want to call it. This is a West Penn Wire specific thing that they've developed to make the installation of what we call Cleave and Crimp connectors very sure. And to do that, they've produced this piece of equipment here, which has a laser in the bottom of it that you stick in there, and then the laser light comes out here. It's coming to here. There it is. The laser light is what's it doing? Hang on. There we go. The laser light comes out here. Notice I'm not looking at it directly. I'm looking at it bouncing off my finger. But the laser light comes out here, and this is going to help us get our connector together. We turn that off so we save the battery, and we'll do that. And we have our cable, our fiber strand that we're going to use, and you'll also notice over here in the corner I've got some Scotch tape, and this will come into play in just a little bit. So those are the things we need to put our connectors together and to install them in the Brilliance, to install the Brilliance connectors. Okay, what we are doing with these Beldon Brilliance connectors, and this is a technology that's been around for a while, is called Cleave and Crimp connectors. In the old days, you would insert, this is a side view, cutaway view of a connector. And in the old days, you would insert a fiber all the way through, and then you would have to prepare this end, and you would have to sand it with various grades of sandpaper, and you glued the fiber into the connector. Very messy, very time consuming. It worked, but it's hard to do, and it takes a lot of time. With Cleave and Crimp connectors, you can install a connector in 5 minutes if you know what you're doing, and by the end of this video, you're going to know what to do. How do these work? Well, in a Cleave and Crimp connector, in the ferrule end, that's the tip of the connector, that's the part here, and of course this isn't drawn to scale, and I'm certainly no artist, but in the ferrule end, there's pre-installed a stub of fiber that has been already polished at the connector end. This is also called stub technology. It's perfect on this end. This is the end that's going to go into the optoelectronics, or it's going to go into another fiber. This end is perfect, as is this end inside the connector. Now what we're going to do is take our cleaved fiber end, and we're going to insert it into the back of the connector so that it touches this fiber inside. When the two of them are touching, then we're going to activate the adapter mechanism that is going to clamp the fiber that we've inserted in here, touching this, and we're going to have a great connector. That's how it works. Cleave and Crimp connectors have been around for 12, 15 years. The technology has greatly improved since it started. And you're going to see with the Brilliance connectors that this is really the state of the art in doing these connectors, because you'll be able to visibly see that the fiber you've inserted, or I'm going to insert, is touching this part here. That's where the laser comes in. Other manufacturers build Cleave and Crimp connectors, and they're okay, but you can't tell if they're good or not until after they're done and you test them. This can be problematic. You have a connector on each end, you put them on, you don't know if they're good or not. You did your best, and you think they're good, but you're not sure. You put your tester on, and the fiber tests bad or mediocre. Now, you got end A and end B. Which end is bad? You don't know. So what do you have to do? Guess. Cut off B, reinstall it, test again. Maybe you got lucky. Maybe it was B. You know what? Mr. Murphy's not going to make it lucky for you. You're going to end up cutting off both ends and redoing both ends. Time consuming, wasteful of product, wasteful of time. So you're going to see with these Brilliance connectors that you're going to have a positive indication that the connector is going to be good because of the laser light and the jig that I showed you. One of the things we have to do is, as we get closer to actually inserting the glass into the back of the Brilliance connector, is we have to measure it to make sure that it is at least 8 millimeters. So this is where we whip out the ruler again and we take a look and we say, is that baby 8 millimeters? Yes, it is, looking good. And then we look at this one and we say, is that thing 8 millimeters? And we say, yep, looking good. Now, one of the things we're going to do is we're going to pull our Sharpie out again, and we're going to mark the outside jacket of these at 13 millimeters. This is per the instructions for the West Penn Brilliance connectors. This is going to give you a visual indication of that you've inserted the fiber far enough. But let me point out to you that the real indication is the feel and also the light that you'll see. So I'm going to mark both ends of my fiber. Here, at 13, I'm going to mark the 13 millimeters back from the end, so I'll know how far to insert it with the orange jacket. And so that is how we measure our cleave length, and we mark our fibers so that we know what we're going to do when we do the insertion. Okay, we measured our cleaves, we marked our fiber, we're good to go. So we're going to take one of these Brilliance connectors, we're going to remove the dust cap, and by the way, the dust cap is your friend. Anytime a fiber is not connected or a connector is just laying out loose, the dust cap should be on it. So we're going to take that dust cap off, we're going to insert the connector, it happens to insert upside down. Now, I'm going to turn on the laser here, push the button here, and you see that I have laser light coming out of right here. That is what we call the window, or the activator window, on the Brilliance connector. Now on a Brilliance connector, on this jig, there is this little stylus or little tool that pulls out, and you're going to need this thing. Because what you do with this is, right here where the laser light is coming out, this is what's called an activator tab, and we push it. Right now it's in the closed position. We're going to push it to the open position. We're going to try to anyway. Come on. Am I holding this thing on or what? And hold on. Let me get a good look at it. It's kind of hard to do these things sideways. Okay, so I have pushed the tab forward towards the front of the connector, and that's what I do with the stylus. Now, this is where the Scotch tape comes in, because I'm going to take this fiber here and I'm going to put it onto the Scotch tape, just the very tip. This fiber is laying on the table, and it can pick up dirt, and fiber and dirt do not get along. Any small amount of dirt on the end of this fiber could cause my connector to be no good. So I use Scotch tape to clean the end of the fiber to make sure it's absolutely clean before I do the insertion. Now, what you do is you lay your fiber along the tool here. Okay, and you'll notice the tool's got some, you can use this as a ruler as well if you chose to, right? And now what I'm going to do is I'm going to insert my fiber into the end of the connector. and I'm going to insert it until I can feel it stop. There it has stopped, and you'll notice that you can see my mark here where I've done my insertion, and notice I have light coming through here. I don't want that light to come through. So what I have to do is maybe wiggle it around just a little bit. Maybe have to try to pull it out and turn it a little bit. Right there. Okay, right there. There's no light coming through the window. Everybody see that, right? Now, we take our stylus tool and we hit the activator, push it back. Now that connector is made and that connector is done. That's all it is. That's all it takes. Just look, watch for, make that light go out. You may have to real gently. Fiber optics is a very gentle science, very gentle technology. Real gently, you might have to rotate the fiber just a little bit, might have to do a little wiggle with it, but once you get that light to go out here, that means all the light, all the laser light is coming out this end, right? So we're good to go. So now we take this one out, and we're going to take the other one. We are going to take the dust cap off, right? We're going to insert it into the jig here. So it's inserted, and you see the light here. I'm going to push the activator tab forward, so it opens the activator tab, and it's also it's the activator tab that clamps the fiber once you got it lined up. And these things are a little harder than they perhaps should be to do, but there it is. I've pushed forward my activator tab. Now, I take my other end of the fiber, I clean it on the Scotch tape, and I take it and put it into the jig, and the jig is ergonomically designed. West Penn did a real nice job building this device because it's very ergonomic. It's very easy to get the fiber to insert into the back end of the connector. So I'm left-handed, so I'm inserting it in here. I missed it. Sorry. Let's get it in there. There it is. Now I'm inserting the fiber into the connector. It's not inserted all the way yet, and I may have to move it around a little bit to get it to go in. There we go. I've inserted the fiber into the connector. Oh, darn it. I had the light go out. It was cool. Okay. Now the light's out, right? You see the light is out in the little window. I'm good to go. I take my stylus end and I hit the activator clamp. Now, I hit the activator here, the light came back on. I don't like that very much, so I'm going to reopen it here, and now the light's off, so I'm saying this is good. So I take my connector, I disconnect it, I turn my laser off to save the battery. I take my boot and I slide it up to put it onto the end of the fiber, and you just slide it up. Now, let me point out one thing here. There's very little strength holding this fiber into this connector right now, and if you pull back here, if you pull on this orange fiber, try to pulling out of the connector, it's going to ruin the connector and make it bad. You're probably going to break the fiber too, so don't do that. Real gently. Slide your boot up and it just kind of screws on, or it kind of slips on, and there you have a completed connector. Now once your connector is completed, we put our dust caps back on, because always put the dust caps back on when you're done. And now we have completed our fiber optic jumper that we built with the two LC connectors from West Penn Wire, the Brilliance connectors. We're pretty much done with this. Now in the next section we're going to test this to see how good it is. And I want to talk a little bit about this stylus thing. It's very important. Keep the stylus. You're going to need it. Okay? So it goes back into the tool, slides into its little holster, and we're good to go. To test a fiber optic link, the only approved test from per the industry standards is to use what's called an optical loss test set. That's what you see right here. This optical loss test set comes from Ideal Networks, American made, beautiful thing. and this piece happens to fit in the bottom here, but for storage purposes, but usually the piece is out. And what we've got here on this side is we have a light source. The light source is set to the wavelengths that are used in fiber optics. Now we're going to test 50 micron multimode fiber, so we're going to test it at 850 nanometers. So I'm going to turn on my light source, and I've got this now set at 850 nanometers. This light source, I have an adapter on here because it has an SC connector. These jumpers are blue because these blue or aqua indicates 50 micron fiber. If you're going to test 50 micron fiber, you need 50 micron jumpers. Okay, so I've got 850 nanometer light coming through here. By the way, this light is above the range of human vision. You can't see the light coming out of here because you can't see it, just like dogs can hear stuff we can't hear. On this side, we have the power meter. The power meter, we turn it on, and it says null. It says null because there's no light power coming into it. It has a connector on top, right here, and it also has a jumper on it. And the jumper has a barrel. I call them barrels, but some people call them adapters. That's this thing right here. This thing right here is what mates two Larry Charlie or LC connectors together. So the first thing I need to do is I need to zero out my meter. So I'm going to take this jumper. Every time I hook them up, I'm going to clean them on the Scotch tape. I'm going to hook up the light source to it. And you'll see here now we're reading like negative 6.2, negative 6.4 dBm. That's decibels reference to 1 milliwatt. So it's less than 1 milliwatt of light power. But if I press the 0 button, which is here, now I read 0 dBm. Pardon me, scratch that, 0 dB. And that means I'm ready now to test my jumper. So to test my jumper that I built, I'm going to take the jumper right here, and here it is. I'm going to disconnect the light source in the meter. Oh, by the way, once you have zeroed these out, you don't down power them or disconnect the connectors from the top until you're done testing everything you want to test. Okay? You leave them powered up, because if you power them down, you're going to have to re-zero them, which isn't a big deal. But keep in mind that we're testing a little 2 or 3 foot jumper here. Your fibers are going to be 1,500 feet long, and to have to re-zero the meters, first of all, it becomes a 2-person job to do the testing. Second of all, to re-zero them, you got to get back together, zero the meters, wasting time. So don't power them down once they're zeroed. Then we take an additional adapter, or I call them barrels just because the original ones were round, okay, for the round ST type of connectors. I'm going to take my 2 connectors that I built. I'm going to remove the dust caps here, and I'm going to clean them on the Scotch tape over here. I'm going to insert one of them into this adapter here, and the other one I'm going to insert into the adapter over here. Excuse me. No, I'm not right here. Hang on. I'm going to insert one of them into the adapter over here. Okay. Now, what I'm holding in my hand here, 2 connectors and 1 adapter. Per the EIA-TIA standards, this can have 3/4 of a dB of loss. Understand mathematically sort of what we just did. We had our jumpers zeroed. Then we added 2 connectors, the 2 connectors we built, and we added 1 barrel. So we added what should be 3/4 of a dB of loss or less. It doesn't matter if it's multi-mode, single mode. Doesn't matter if it's 50 micron or 62.5 micron multi-mode. We should have an optical loss of the connectors when we hook them up that should be equal to or less than 3/4 of a dB. And if we look at our connectors right now, we're going to see that these connectors are showing somewhere between 0.05 and 0.1 dB of optical loss. Now it's jumping around a little bit because you'll see that happen. As the cables are moved around a little bit, the loss value will change somewhat. But you're looking at a pair of what are perfect connectors. Now, when I teach fiber classes, sometimes the guys get excited. Well, my connectors are better than your connectors because my connectors were 0.3 of a dB and yours were 0.4 of a dB loss. Doesn't matter. There's a window of acceptability. That window is 0.75 of a dB or less per connector set. As long as you're in that window of acceptability, you're good. Anything below that is fine. And frankly, if you tested a connector set and it tested to 1 dB of loss, I'd leave them on. I'd just roll with it because most of the devices that you hook these things up to, they can take 12 or 13 dB of loss and still function properly. 1 dB, a quarter of a dB loss here and there ain't going to matter. Pardon me, isn't going to matter. However, if I hooked up my fiber I was testing and it showed 7 dB of loss, something's wrong. So something's wrong with these connectors. But as you saw with the Brilliance connectors, you can see with the laser light, when the light goes out, you are good to go. Okay? So, we built ourselves a jumper. It's perfect. It's as good as it gets. That's what you get with the Brilliance connectors from West Penn Wire. You may have noticed in the excitement of me building the jumper we just built that I forgot something. And what I forgot to do is on this side here, I forgot to install the boot, which is in my hand here. This is a very common problem. You're working and you forget to put the boots on. The beauty of these Brilliance connectors from West Penn is that in many cases they can be reinstalled or reused. So that's what we're going to try to do right now. So I'm going to take my jig here. I'm going to insert the connector here. And now I'm going to slide the activator tab open so I can pull the fiber out. So my activator tab is open and I can slide my fiber out. You see the laser light right here. Now I'm going to take my boot, don't worry about that, and very gently I'm going to insert the fiber into the boot. Got to be careful here because the fiber is going to be really delicate when it's been all stripped and everything. So now I got my boot on, so now I can reinstall this. So here's what I'm going to do. I'm going to line up my fiber in my connector. Remember, this connector already had the fiber in it. And I'm going to slide it back in. And I'm going to make that light go out if I can. Takes a little doing sometimes, a little wiggle here and there. Right there. You see the light's out. Notice I'm pushing forward on this, getting a little bend here. It's pushing it forward for me. My light has gone out. Now, I clamp it. I move the activator tab up here. The laser light's coming out on this end. Beautiful. Turn our laser off. Get our test meter out. We've got our test meter. I'm going to make sure it's still zeroed. So I'm going to plug the lead from the light source into the lead from the power meter. It's reading 000 dBm, which is great. I'm going to take my boot and I'm going to slide it up to the connector that I just put back together again. And now I'm going to clean these connectors on my Scotch tape, wherever it went. Here, let me get a new piece. Get this out of the way. And now, I'm going to take the lead, the test lead from the light source. I'm going to hook it up to one side of the connector. Remember, this connector set was showing about negative 1.1 dBm, or dB, I'm sorry. And then I'm going to clean the other end, and I'm going to hook it up to the power meter here. And we're reading 0.2 dB. Again, the industry standard would be 0.75 or below. So, one of the beautiful things about these Brilliance connectors is the ability to reuse them. to fix them. Basically, when you plug it into the jig, if you think you have a problem and you plug it into the testing jig with the laser turned on, if you see any laser light coming out of the adapter, the sliding adapter control window, then you know that's the end, that's the problem. So we have here we have replaced this connector end. We did it again with the West Penn Brilliance connectors. These are beautiful things.